Anjali Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. This is our second lecture of the Control System 1, and this video has been made for the Electrical Engineering third year students for the course of Control System 1. In this video, we will discuss on the control system, the requirements of a good control system, the classification, open loop and closed loop system, comparison between the open loop and closed loop system with the practical examples and the effects of the feedback. So, what is a control system? When a number of elements are combined together to form a system that can manage, command, direct or regulate the behavior of other devices or the systems to produce the desired output, then it is called the control system. As the system controls the output, so it is known as the control system. Each element connected to the system has its own effect on the output. A control system is a system which provides the desired response by controlling the output. So, the given figure shows the simple block diagram of a control system, where input is given to a control system which is the combination of different parts, and according to this input the system produces an output. Now, the human civilization is being modernized day by day. The demand of the automation is increasing accordingly. So, automation highly requires the control of devices, and in recent years the control systems have played a central role in the development and advancement of modern technology and civilization. Practically every aspect of our day-to-day life is attached less or more by some control system. A toilet tank, a refrigerator or an air conditioner, geyser, even an automatic iron are control systems. These systems are also used in industrial processes for more output, and we find control systems in quality control of products, weapon systems, transportation systems, power systems, space technology, robotics and many more. So, the system used for controlling the position, velocity, acceleration, temperature, pressure, voltage, current, all can be considered as the examples of a control system. Next, the requirements of a good control system. So, to be a good control system, first requirement is the accuracy. The accuracy is the measurement of tolerance of the instrument and defines the limits of the errors made when the instrument is used in normal operating conditions. The accuracy can be improved by using the feedback elements. To increase the accuracy of any control system, error detector should be present in the control system. And the next requirement is the sensitivity. The parameters of the control systems are always changing with the change in surrounding conditions, the internal disturbances or any other parameters. This change can be expressed in terms of sensitivity. So, to be a good control system, it should be insensitive to such parameter variations, but it should be sensitive to the input signals only. And the next one is the noise reduction. An undesired input signal in the system is known as the noise. So, a good control system should be able to reduce this noise effect for its better performance. The next is the stability, which is very important characteristics of the control system. For the bounded input signals, the output must be bounded and if the input is 0, then output must be 0. Then such control system is said to be a stable system. And next is the bandwidth. For operating frequency range decides the bandwidth of a control system, and bandwidth should be as large as possible for the frequency response of a good control system. And the next one is the speed, which is most important, and it is the time taken by the control system to achieve its stable output. A good control system possesses very high speed. So it means that the transient period for the system is very small. And last is the oscillation. A small numbers of oscillation or constant oscillation of output tend to indicate the system to be stable. So to be a good control system, these are the important requirements of a good control system. Next is the classification. Now, depending upon the purpose of classification, any system can be classified as per follows. So, first, as per the method of analysis and design, we can classify it as a linear system or non-linear system. Now, linear systems made of devices which obey the superposition principle, and they are governed by linear differential equations. Whereas the nonlinear systems covers a wider class of systems but do not obey the superposition principle. Now, according to the relation of the parameter with time, we can classify it as a time variant system or time invariant system. So, from the name we can say the input characteristics does not change with the time, or output characteristics does not change with the time, then the system is called time variant. And time invariant means with respect to time, the input characteristics or the output characteristics does not change. And if we consider an example, the mass of aircraft changes as the fuel is consumed. So it is a time variant system. Now, as per the time of the signals used in the system, it can be classified as the continuous system and discrete system. In continuous time control systems, all the signals are continuous in time, but in discrete time control system, there exists one or more discrete time signals. Next is as per the number of input and output, the system is SISO or MIMO. So, single input and single output system is a simple single variable control with only one input and one output. And last but not the least, as per the presence of the feedback, the system can be classified as the open loop system and the closed loop system. The open loop system means the output of the system is free from their input, and in the closed loop system, the desired output depends on their input. The open loop system is called non-feedback system, as no feedback is connected with it, whereas the closed loop system is known as the feedback system. So let us discuss more on the open loop system and closed loop system. In an open loop control system, the output is not feedback to the input, so the control action is independent on the desired output. So the following figure shows the block diagram of an open loop control system, whereas the input is directly fed to the controller, and as per the input, the controller takes the control action and it produces the actuating signal. This actuating signal is used as the input of the plant, and as per the actuating signal, the plant produces the output. So there are some features of the open loop control system, such as it is simple in construction and design, it is very economical and easy to maintain, Generally, these are the stable systems and it is convenient to use. Output is difficult to measure. But the most disadvantages of open loop control systems are actually there is no feedback path is present. So the control action is independent on the desired output and hence they are inaccurate. Also they are unreliable and any change in the output cannot be corrected automatically in open loop control system. So to overcome these disadvantages, the closed loop control system has been considered. And in closed loop control system, the output is feedback to the input. So the control action is dependent on the desired output. So here this is the block diagram of closed loop control system. Here instead of the input is directly fed to the controller, the reference input and the feedback loop goes to the error detector. And the output of this error detector is actually the algebraic sum and or algebraic difference between the different inputs coming to it. So here the error signal is produced, whereas this error signal is actually the difference between this reference input and this feedback signal. And this feedback signal is actually the portion of the output. So in closed loop control system, a portion of the output is used as the feedback signal and the difference between this reference input with this feedback signal is going to the controller of the system. And as per this error signal, the controller takes the control action and it creates the manipulated variable or the actuating signal which goes to the process, and as per the signal the process will create the output. So here are the we can take an example, and these are the features of the closed loop control system, where the closed loop control systems are more accurate even in the presence of non-linearity, and high accuracy as the any error arising can be corrected due to the presence of the feedback. Now here the bandwidth range is large and the system is less affected by the noise. But there are some disadvantages in this closed loop system too. Those are the costlier and complicated to design, which requires more maintenance, and feedback leads to the oscillatory response. So let us take an example of a simple temperature controller of the room to get the clear concept of closed loop control and the open loop control. So suppose there is a simple heating element which is heated up as long as the electric power supply is switched on. As long as the power supply is switched off, the heater or in the temperature of the room rises, and after achieving the desired temperature of the room, the power supply is switched off. Again, due to the ambient temperature, the room temperature falls, and then manually the heater element is switched on to achieve the desired room temperature again. In this way, we can manually control the room temperature at the desired level. And this is an example of the open loop control system or the manual control system. Now, this system can be further improved by using the timer switching arrangement of the power supply, where the supply to the heating element is switched on and off in predetermined interval to achieve the desired temperature level of the room. So there is another improved way of controlling the room temperature, that means one sensor which measures the difference between the actual temperature and the desired temperature, and if there is any difference between them, the heating element functions to reduce the difference, and when the difference becomes lower than a predetermined value, then the heating element stop function. So these systems are automatic control systems, and for the previous one, the input of the system is entirely independent on the output of the system. The temperature of the room that is the output increases as long as the power supply switch is kept on. That means the heating element produces heat as long as the power supply is kept on and the final room temperature does not have any control over the input power supply of the system. And this system is referred to open loop control system. But for the second case, the heating element of the system function depending upon the difference between the actual temperature and the desired temperature. And this difference is known as the error of the system. So this error signal is feedback to the system to control the input. As the input to the output path and the error path created a closed loop. So this type of closed system is known as the closed loop control system. So here are some disadvantages such as it required more maintenance or feedback leads to the oscillatory response. Overall gain is reduced due to the presence of feedback, and major problem is the stability. Still we are using the closed loop control system due to this accuracy and the speed of response. So let's take some practical examples of open loop system and closed loop system. So if we consider the open loop system first, then we can assume the automatic washing machine which runs according to the preset time irrespective of washing is completed or not. Or another example can be considered as the electric hand dryer where the hot air comes out as long as we can keep our hand under the machine irrespective how much our hand is dried. Or the bread toaster which runs as per the adjusted time irrespective of the toasting is completed or not. Another example of open loop control system is automatic tea or the coffee maker. These machines are actually function for pre-adjusted time only. The same is applicable on the timer based clothes dryer where the machine dries the wet clothes for pre-adjusted time which does not matter how much the clothes are dried. And the light switch, the lamp glows whenever the light switch is on irrespective of the light is required or not. So all these are examples of open loop system. And next is the closed loop system. So for closed loop system we can consider the servo voltage stabilizer where the voltage controller operates depending upon the output voltage of the system. Another example is water level controller where the input water is controlled by the water level of the reservoir, and here the level transmitter is used for the feedback element. Another is missile launched and auto tracked by the radar where the direction of the missile is controlled by comparing the target and position of the missile. Or the air conditioner which functions depending upon the temperature of the room or the cooling systems in the car which operates depending upon the temperature with its controls, and also the human body which is an example of closed loop control system. So next discuss on the comparison between the open loop and closed loop system. So in case of open loop system there is no feedback, and in case of closed loop system feedback is always present. In open loop system the input is directly fed to the controller, whereas in case of closed loop control system instead of the reference input the difference between the reference input and the feedback signal is fed to the controller through the error detector. So in case of open loop system error detector is not present, whereas the error detector is always present in case of the closed loop control system. The open loop control system is easy to construct and it is economical, whereas the closed loop control system is costly and complicated in construction. Open loop control system is maybe stable one, but closed loop control system may become unstable. In case of open loop control system, the bandwidth is always less, and for the closed loop, it has the large bandwidth. And for the open loop, it is inaccurate and the maintenance cost is less but also unreliable. Whereas in closed loop control system, it requires more maintenance, it is accurate as well as reliable. And we have already discussed on the different examples of the open loop and closed loop controls. So let's take the example of effects of feedback. So what will happen if we use the feedback in a system? So this one is the block diagram of a feedback control system. That means actually a closed loop control system. Whereas this R is the reference input and E is the error signal. E is actually the algebraic sum or difference between this reference input signal and the feedback signal, and B is the feedback signal. G is the forward path gain, and C is the output of the signal, and H is the feedback. So this error between the system input and system output is gradually reduced, because it's every time we are taking this output of the as a feedback, and as per this feedback the error is producing, and error is the difference between this reference input and this feedback signal, and as per this error signal it takes the controller action, and after this action it will be rectified, and then the feedback is again decreased, so either decreased or increased, so the error goes to decrease gradually. Now the system gain is also reduced, and the sensitivity of the system has been increased, but the stability may be affected due to the use of the feedback, because in closed loop system overall gain is reduced, but the stability, which is the major problem, and more care is needed to design a stable closed loop system. But the speed of response is increased. Speed of response means it takes the time to go to the stable system. So all are the effects of the feedback, and overall the closed loop system has more advantages than the open loop system. So in this video we have discussed on the classification of the control systems, closed loop system and the idea of open loop system, the practical examples between closed loop and open loop system, the comparison between them, and the effects of the feedback of the system. These are the references. In the next video, we will discuss on the mathematical modeling of the control systems. Thank you.
Hope after this video lecture you have a clear idea about today's topic. Now we will go through some questions and answer session in the context of this video lecture. Now you are requested to go through gradually and try to solve the MCQ questions by your own. Answers are